Hello, hope you guys all are fine and doing great. And I'm Ibtisam, and you guys are watching Coding Devs. And this is going to be the third tutorial video on building decentralized exchange. And in the last video, we have built the first smart contract for our decentralized exchange because, as I mentioned, this decentralized exchange is going to have multiple smart contract, and this is our first smart contract and we named it wallet. And this wallet smart contract is going to have the balances for each token, and also it is going to store the token information, the token ticker, the token address, and we need the token address to transfer the tokens to the user, to the actual owner. And then we also need the token address for the deposit function, for the withdrawal function. So yeah, this is the struct that we have created in the last video, and then we are going to store all the tickers in the bytes 32. So yeah, and then we have built the first function, which is going to add the tokens in our smart contract. And for that, the user it is going to have two arguments: the ticker, the symbol of the token, and the token address. And this is how we are going to store the tokens in our decentralized exchange. And now we are going to build the first function, build the other functions. And in this video we are going to build the withdraw function. So the withdrawal function is going to work like the user can withdraw its tokens from our smart contract, from our decentralized exchange to his or her wallet. Okay, so this function is going to work like this. And again, if the user is going to withdraw its tokens, then it is going to be an ERC20 contract. So we have to communicate with the ERC20 token contract. So whenever you are going to communicate with the external contract, you should have two things. The first is the interface of that contract, and we have successfully imported the interface for the ERC20 contract from the ERC20 folder from OpenZeppelin. So we have imported the one line of code, and now we are going to use the interface. And again, the second thing is the address. Whenever you are going to communicate with the external contract, you should have the interface and the address of that contract. So, and yeah, and this is how a withdrawal function is going to work like this. And now we are going to use the interface because this function is a withdrawal function, so we have to run the transfer call. And how we are going to run the transfer call so that we can transfer the user tokens from our decentralized exchange to the user wallet. So how we are going to use this transfer call? So I'm going to use one line of code. We have to use the interface. Okay, we have to use the interface. And again, the interface needs an address. An address we are going to give it like in this form, like where is the address? So we are going to use the token mapping, and with the help of token mapping we are going to use with the help of ticker, we are going to redirect this ticker to our struct. And in this struct we have this token address. So in the token mapping we have to put the ticker, and then in the ticker, now we can move into our struct to get the token address. And now we are going to use the transfer, the built-in function, and this transfer function is going to have this transfer function needs two arguments. The first is the address, and this address is going to be the user address, the one who is calling this, the actual owner. And then the second one is the amount. It's fine, it's ready. But now we cannot transfer the tokens from our decentralized exchange to the user. We have to put conditions. We have to put the required conditions. First of all, we are going to check the user balance in our decentralized exchange, because if there is no balance for that user, then he cannot withdraw it. And because so we have to put some conditions. So this is just a transfer code, and this is just a transfer. And now we are going to add some conditions. And how we can add some conditions? So first of all, as I mentioned, like we are going to check the user balance in our decentralized exchange, and we are going to check it with the help of require. And now this require is going to check the balance of the particular user. Okay, and now how we are going to check it? We are going to use this balances mapping, and this balances mapping it's a double mapping. So it's a double mapping, so it needs So first it needs an address, and then it needs a bytes 32 data type. So the address is going to be the user address, okay, and then it needs a it's a double mapping, so it needs a bytes 32, which is going to be the ticker of the particular token, so that we can check the user balance with the particular token. And now the user balance should be greater than the withdrawal amount, and if it's not, then we have to then we have to show some error, and we can write it like the balance not sufficient. Okay, okay, yeah. So we have put the first condition, like this condition is going to check the user balance, and now we are going to add one more condition. So like the second condition is like the token the withdrawal token should be in our decentralized exchange, and if there is no token in our decentralized exchange, the particular token, then we have to show some error. And again we are going to use it with the help of require, and this require and now like to check the token in our smart contract, we have to check this token mapping, okay, because this token mapping it's going to it is need a byte 32, which is going to be the ticker, and then this ticker it is going to redirect to our struct, and we can check the token address. Okay, so with the help of token mapping, this token mapping needs a ticker, and then we can move to our struct, and in the struct we have the all the information about the token. So this so it should not be equal to the address of 0. So that is how we can check like if there is a token in our smart contract or not. And yeah, this is, yeah, I think this is fun, this is fine. So first we are going to check the token. If there is if it's a token in our smart contract, the particular token that the user wants to withdraw from our decentralized exchange to its wallet, if it's, then it is moved to the second line of code, this line of code, then it is going to check the user balance. And if there is a sufficient balance, then it is going to be it will transfer that amount from our decentralized exchange to the user. But we have to add one line of code more, and obviously when we transferred the user balance from our decentralized exchange to its wallet, then obviously the balance should be updated. And how we can update the remaining balance? So again we are going to use the balances, and this is a double mapping, and we have to update the balance after the transfer call. So this is a double mapping, and where is the double mapping? This. So first it needs an address, and the second it needs a byte 32, which is going to be the ticker. And then we are going to I think yeah, why I'm going to. So first it needs an address, and then it needs a ticker. And now we are going to okay, and now we are going to update the user balance with the help of safe math, because and now I'm going to use the safe math library. And why I'm going to use this library? Because I want to get rid of the underflow and the overflow error. And yeah, and let me write one line of code more. So msg.sender, because we have to update the balance. And now I'm going to use the sub function from the safe math. I have not imported the safe math library yet, but let me write this, and then we can import the safe math library. So yeah, this is how we can update the user balance after the transfer call. So first we are going to use the balances, and this balances mapping needs to because this is a double mapping, so it needs an address, and then the second it needs a ticker, the bytes 32 of the token. And then we can subtract the amount from the withdrawal, okay, from the previous amount. And now we have to import the safe math library. And where is the safe math library? I think it's in the math token. Where is the math folder? I think let's just see. Mm-mm. I think there should be a math folder, but I have not. Utils maybe. Yeah, I think there is a math and we can have it. Yeah, so it's in the so let's just copy this line of code, and it's in the open zeppelin, and it's in the contracts folder. Maybe, yeah, it's in the contracts, and then in the contracts there is a utils folder, utilities. Okay, and then in the in the utilities folder there is a math folder. Okay, and then in the math folder we have the safemath.sol smart contract, because we have to use it to get rid of the overflow and the underflow error. And what are these error? You guys can google it. So yeah, and now we have successfully import this smart contract, and we also have to write it here, one line of code, like, because we are going to use this sub function from the SafeMath smart contract for u in 256, because this amount is a u in 256. So we have to write one line of code is like SafeMath, using SafeMath for u in 256. Yeah, and this is going to be so that this line of code works like so the SafeMath will be available for the u in 256 data type. So yeah, and now this is done. Yeah, now our withdrawal function is complete, and we have put all the conditions, all the necessary conditions. So and then the user can withdraw the smart contract, withdraw the tokens from our decentralized exchange to its wallet. And yeah, and let's just complete this tutorial video. And now in the next video we are going to extend our smart contract, this wallet smart contract, and we are going to build the deposit functions. And yeah, that's it. So that's it from this video. Hope you guys have a nice weekend, and good luck. Bye bye.